You're listening to the Mushroom Revival podcast.
What if we told you that fungi were involved in an ancient Egyptian curse?
Or if fungi create a natural antifreeze?
Or if fungi actually helped dismantle slavery in the United States?
So today on the show, we've got a sample platter of mushroom stories selected from Lawrence Millman's Fungipedia. This is a great episode to share with your myco-curious friends, where we visit some of the unlikely corners of fungal existence. And what is Fungipedia about?
It's a miscellany. The subtitle is A Brief Compendium of Mushroom Lore. So I have science, information about fungal sex, biographies of different mycologists. There are about 175 entries in the book. I'll mention to you, I think edibility is the least interesting aspect of any mushroom.
So for our first Fungipedia piece, forget about us eating fungi. What about fungi that eat us?
There are some fungi characterized as keratinophiles or keratin-loving. They are found in an order that I believe is pronounced Onigenalis, which include fungi that secrete a special enzyme with the ability to digest keratin proteins, which is found on the outer layer of our skin. So it's no surprise that we find these species living on us.
But don't worry too much. These fungi won't take over your mind or eat you from the inside out like cordyceps. In fact, many, if not all of you, are probably being snacked on by these fungi right now. Common occurrences like dandruff and acne can be from a keratinophile known as mycelia or Pitrosporum. It's normal to have these on your skin, but it can begin to express unwanted signs as the fungus grows into the pores. Not so common issues like athlete's foot, ringworm, and jock itch all come from keratinophiles in a genus called Trichophytum.
Pro tip, since fungal acne and dandruff is common, we thought we'd shout out parathinone zinc, a molecule that supports healthy skin and is recommended by dermatologists for conditions related to these fungi. More on that in our show notes.
And for our animal friends, there is a species commonly called horned stalkball that feeds on rotting hooves and horns. And this fungus will actually fruit tiny little white mushrooms all over it. Let me tell you right now, you have to Google image this one, horned stalkball. It's pretty metal.
To segue from skin and hooves, our next piece is about hair. There is an unusual phenomenon known as hair ice, where ultra-thin crystals of ice form on the outside of dead branches. The ice itself is not a fungus, but it does need a living fungus for it to occur. So on early winter mornings when the temperature is just below freezing, and if the air is humid, and you're between 45 and 55 degrees latitude, you may get lucky and find hair ice growing off of dead hardwood branches.
This is another one you have to look up pictures or videos of this stuff. It looks almost like silvery human hair. It's the same thickness and can actually grow up to 20 centimeters long. When conditions are just right, a magical event known as ice segregation occurs when the water inside the wood starts to freeze. But instead of forming ice, the water becomes supercooled, thanks to some interaction with molecules inside of the wood. But ice does form on the outside, at the opening. Think of this like the hair follicle.
And between these two states of water, so you've got your frozen bits on the outside and your supercooled water on the inside, more ice will form right at that interface and continue to grow until all of the water inside of the branch is completely used up. One of the reasons this only occurs in hardwoods is due to their porous structure known as medullary rays.
The original thought was that these formations were due to gas pressure inside the branch that forced out the freezing water. But that was proven wrong in 2005, when scientists showed that the fungus was the key to these fine crystalline structures. Nearly a century later, a German geophysicist by the name of Alfred Wegener, who was also a leading scientist in continental drift, suggested that a fungus was involved. Scientists proved this theory in the 21st century by showing that if you kill the fungus in the branch, the hairs no longer grow.
So what is the fungus actually doing? It's still not totally clear, but it's likely due to some special proteins secreted by the fungus known as recrystalline inhibitors. These are similar to the proteins found in some animals that prevent the water in their cells from freezing. So it's basically like a fungal antifreeze. And when it's combined with water, it gives it durability. That's illustrated when we acknowledge that the hair ice can stick around for hours or even days despite fluctuating temperatures, whereas any other normal fine ice crystals would melt and recrystallize into amorphous, uninteresting clumps.
Hair ice is found pretty up there. So this occurs at 45 to 55 degrees latitude. That's northern US and Canada. But even when we go higher near the Arctic, fungi are still showing up. And Lawrence Millman, who has an affinity for the cold, unlike myself, has spent lots of time in the Arctic region looking for fungi. He has some unique insight into the mushroom culture in Greenland.
In East Greenland, there is incredible phobia about mushrooms, and they're called Keratinophilic sopa. And Keratinophilic are mountain hermits who can twitch their fingers and go flying through the air, which they do. And they fly into a village, grab somebody, and take that person back, or they'll eat him on the premises, or take him back, dry him, and eat him later. And because in the farther north you go, in the later the season, mushrooms tend to be slimy, and slime is an antifreeze. So if you see in November slime on certain mushrooms like Cortinarius, etc., it is to protect the mushroom against freezing. And in East Greenland, it gets cold earlier than other places, and there's a lot of slime. And the mushrooms are called Keratinophilic sopa. Sopa is the word for soap. So it's thought that this slime is what the Keratinophilic uses to bathe with. And if a Keratinophilic uses it to bathe with, you certainly don't want to eat it, nor do you want to have anything to do with it. And that explains why in East Greenland there tends to be a phobic attitude toward mushrooms.
It's fascinating because these are areas that most people don't tend to look for mushrooms, and I'm sure there's a lot of species that are new to science. We're finding species in Antarctica that no one would think to look. People tend to look, in forests and rainforests and things like that. But to look in snow and ice, fungi are extremophiles, and they will pop up on every nook and cranny of this earth, and to find out how they're doing it is fascinating.
One of the places that they're popping up in Antarctica is in old explorers' huts. The mycelium, or the spores, remained in the wood and can remain in wood for hundreds of years. Drift logs in the Arctic. People have cultured mycelia from drift logs. The mycelia is 600 years old. Actually, some people have found mycelia in the mummies, Egyptian mummies, and have cultured something that was 2,000 years old.
Wow.
So at any rate, there's a fellow in the University of Minnesota named Bob Blanchette, who's done a lot of work with explorers' hut. Now, there's not a lot of wood in the Arctic or the Antarctic, but there is brought-in wood by explorers and other people, and the brought-in wood, spores and mycelia, just waiting, and they can wait much longer than we can, to produce fruiting bodies. And I can't remember, he found how many, 40 or 50 different species in the wood of Captain Scott's hut in Antarctica. They hadn't fruited yet, but they could fruit with climate change.
So to expand on fungi associated with ancient Egypt, our third piece from Fungipedia features a mold genus, Aspergillus. These fungi like to fruit in dry, closed-off environments like barns and sheds, and also Pharaoh's tombs. The spores of these fungi can survive for a long time in the environment, and when inhaled, they can cause pulmonary issues that result in future complications.
Let's consider King Tut's curse, or Curse of the Pharaohs, where legends say if you disturb a mummy, especially a pharaoh's, you could be cursed with bad luck illness, or even death. In the case of King Tut, who is said to condemn anyone who disturbed his tomb, at least 11 visitors have reportedly died from this curse. Another mystery that might be tied to fungi, perhaps these violators weren't cursed by something paranormal, but rather sickened with aspergillus spores and mycotoxins, which actually is a semi-common cause of death for archaeologists opening old tombs, believe it or not.
Fungi change history. And for our last piece from Fungipedia, the possible role of fungi in the South's defeat during the Civil War. This section was titled Train Wreckers because a fungus, Neolentinus lepidius, a cousin of the shiitake mushroom, was found feasting on wooden railroad ties despite being treated with tar. The faulty railroad ties resulted in dozens of failed attempts at sending trains to support General Robert E. Lee, a commander of the Confederate States.
So shout out to Neolentinus for helping end slavery in the U.S. and for making the world a better place.
And another fun fact, the USDA actually banned imports of shiitake mushrooms since it was a cousin of this so-called train wrecker fungus until the early 1970s in fear that it would erode more infrastructure.
And the mushrooms from this fungi are actually edible. Just not if they've been growing off railroad ties, which will most likely have absorbed some nasty chemicals and heavy metals from the tar and surrounding areas. You're actually better off picking some chaga in a pristine birch forest and going on that train. Chaga chaga choo choo!
In all seriousness, Lawrence Millman has done a lot more than just write Fungipedia. He himself is a special piece of the mycoverse and has had significant impact on surveying fungi in urban and remote environments. He's done a lot of education regarding ethnomycology and the consequences of studying mycology in sterile environments like a lab.
So, in exploring all these different places where people normally don't look for fungi and mushrooms, every once in a while you might stumble upon a rare specimen. Like in 2005, you found a rare polypore that hasn't been seen since 1909. Were you looking for it? You know, do you have a list of rare fungi that you're looking for, or just stumble upon it in a rare circumstance?
No. With respect to that, the polypore is Echinodontium ballouii. It does not have a common name. It grows exclusively on old-growth Atlantic white cedars. So what I did, because I was very eager to see if indeed it was still extinct, was with friends, we went to Atlantic white cedar swamps, always in the winter, because if you go in the summer, the combination of muck and mosquitoes will drive you away very quickly. But in the winter, it freezes and you can walk in on snowshoes or crampons. So I investigated a number of Atlantic white cedar swamps. The problem with Atlantic white cedars and this particular tree is that for the longest time they were used in shipbuilding and house building. And that meant it was very hard to find old growth trees. And this only grows on old growth Atlantic white cedars. And then I had a revelation. A friend of mine simultaneously had the same revelation. Let's find the farthest inland Atlantic white cedar swamp. Because it would have been much harder to transport the wood to the coast from a place 125 miles inland than right on the coast, where I would say a larger proportion of the swamps are. So we found one that was about 125 miles inland. I have been very reserved about indicating exactly where, lest people go and take the remaining species away. But anyway, we went there, found some old growth trees, and indeed they did have specimens of Echinodontium ballouii on them. Maybe we found 25 different species. We kind of thought in advance this would happen. So we brought along a bottle of whiskey to celebrate our discovery. Having found it on a particular tree, what happened was he saw a ruined-looking fungus on one side of the tree, and he said, "I bet that's it." And I said, "Oh, it's impossible to tell." So we went around opposite directions and met in behind, and he beat me by about 10 seconds, saying, "Look, there it is." We saw it there. And about a minute later, I was unzipping my rucksack and bringing out the bottle of scotch. So we had found something that was presumed to be extinct.
Wow.
I have since looked in a lot of other places for it, and including one swamp which has some big old growth trees, and I haven't found it anywhere else.
Do you suspect that that's the only patch of it in the world left?
Yes, I do. One reason why I have stayed away from universities in my pursuit of mycology is that everyone tends to be hemmed in four square laboratories. Their field mycology is becoming similar to the dodo and the Labrador duck. There are 3 field mycologists left in the UK. I'm not sure how many are left here. But myself, I can only manage being indoors for a certain period of time, and then I've got to go outdoors and, among other things, look for fungi.
Yeah, it's got to be a balance. I mean, we have a lot of amazing tools, and molecular biology is extremely illuminating and instrumental to developing some of our most productive and important products, medicines, whatever. But there is some fidelity there if you just are sterilely taking the specimen into the lab, and then you get to know it in that setting. That's not really where it lives. That's, it's like trying to get to know as an animal outside of its wild habitat, and you just are going to miss out on a lot of the really essential behaviors.
And you're going to get some non-essential ones. If you sit in front of a cage of an animal in the zoo and start documenting behavior, it's going to be cooped up behavior rather than behavior in the wild.
Mm-hmm.
Right.
And the other thing is many mushrooms are cultured in laboratories, but the cultured mushroom has differences from its wild colleague. One thing it has eventually is that there's certain chemicals that the mushroom in the wild uses to fight off bacteria that are no longer needed when there are no bacteria around. And a petri dish is usually a bacterially free environment. So you can argue that what's being cultured is a different species from its seemingly same species that's in the wild.
Yeah, I think about this frequently, actually, and especially when I follow a great Facebook group called Agar of Asgard, and people just post beautiful photos of their agar plates.
Huh.
But it's interesting to think that fungus you cultured never had this restrictive two-dimensional landscape to grow on. And, you often see really interesting characteristics of fungi. Like I have probably over 20 cultures, and I could identify the plate just by looking at the mycelium.
Mm-hmm.
But is that what it looks like in a log or whatever substrate it has in the natural world? Like, no way. And
no way.
It's interesting to see some of these fungi express in really intense rhizomorphs and grow in a perfectly radial pattern. I mean, that would just not happen in dung or wherever you had found your fungus. So it is interesting how much their genetic expression has to change in order to thrive in that environment. And I just wonder how much we really lose between those two worlds.
I think we lose a lot. And John Muir said, when you study nature, you find everything is hitched to everything else. But when you take something and remove it to a petri dish, you cut off the hitches, so to speak, and you've simply got itself alone.
Special thanks to Lawrence Millman for creating Fungipedia. For more stories of fungal lore, be sure to get a copy of Fungipedia and check out our show notes for more extensive coverage on these fungal factoids.
If you want to support the show and keep content like this coming, you can do so by visiting our website, mushroomrevival.com, and purchasing any of our functional mushroom products for supporting your energy, calm, focus, immune support, your body's natural ability to adapt to occasional stress and fatigue, Podcast listeners get a special discount for 10% off their first order by entering the code MRPodcast, all capital letters at checkout. That's MRPodcast.
You can also support us by rating or reviewing our show and telling your friends.
And as always, much love, and may the spores be with you.